Algebra 2 Cram, New York State Algebra 2 Regents, Common Core Basics, Trigonometric Functions, Concept number 23, Cofunctions. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is super effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a brand new paradigm. I want to include everyone who needs a boost in Algebra 2. And if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose by ordering the complete Algebra 2 cram session beyond the trigonometry series. You have lots of peers, classmates, friends, or colleagues who are also taking Algebra 2 along with you, and they could really benefit from this cram session as well. So be sure to spread the word and tell them to inbox me at memedicine@gmail.com so that they too can order the complete cram session. You'll be glad you spread the word because they'll make great study buddies. And last but not least, the concept of cramming often has a negative connotation, okay? But what people are actually thinking of is hurrying, which is a result of fear and can consequently be destructive. We're not hurrying here, we're cramming, and there's a huge difference. Hurrying is jam-packing tons and tons of unorganized information into your mental, spiritual DNA over a really tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems like an instant, okay? So let's delve into the concept of cofunctions. Cofunctions. What are examples of cofunctions, and in what instances do the cofunctions of two angles have the same value? Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and arrive at some answers, but if not, that's completely fine. Let's attempt this grand concept together. Okay, so the prefix co in a trigonometric function indicates that two functions are cofunctions. All right, I know what you're probably thinking. That's a circuitous definition, but the defining feature of cofunctions is that cofunctions of two angles have the same exact value if the angles are complementary. That is, if the angles sum to 90 degrees. So complementary angles have the same exact numerical values for their cofunctions. All right, so we're going to delve into this example, but before I show you a concrete exact example, let's establish a few more defining features of this cofunction concept. So let's say that you have your xy Cartesian coordinate plane and you have this angle theta. Okay, this angle theta is obviously an acute angle in standard position with its vertex at the origin, the initial side ray on the x-axis, and the terminal side ray terminating in quadrant 1. And this is a concept this standard position acute angle in quadrant 1 is what we're going to use to define our cofunction concept, okay? And when I say the angle is acute, that's because it's tiny. Tiny meaning its measurement grows in the positive counterclockwise direction, and it's sandwiched between the quadrantal angles 0 degrees and 90 degrees. And when I say quadrantal angles, I mean that the terminal side ray that you see here will fall on the either x-axis or y-axis, which is the case for 0 degrees or 90 degrees or 180, etc. Okay? All right, so let's say that our angle theta, we're going to give it an exact value so we can explore the cofunctions of two angles. Let's say it's 30 degrees. Okay, so what we're going to do now is create our triangle because there's no cofunctions or trigonometric values without it in an actual triangle, okay? So we're going to call the terminal side ray R for short, okay, R being short for ray. Now we're going to do a little bit of magic. We're going to cut this ray off right here at our point P, P being short for point, and point P has the coordinates X and Y, okay? All right, so in our imagination, what we're going to now do is resolve this terminal side ray into its horizontal X component and its vertical Y component. So the ray, the terminal side ray, well, it's no longer a ray, it's actually a segment length, goes to the extent of X in the horizontal direction, and it rises to the level of Y in the vertical direction, okay? And for more details of this whole standard position concept, you can view a tons load of my trigonometry series by ordering the complete Cram session by inboxing me at memedicine@gmail.com, okay? And so looky, what do we have here? We have a right triangle, so let's indicate that, okay? This little square, sorry if it's not drawn to scale, but I think you get what I mean, indicates we have a 90-degree angle right here. This angle is 30 degrees, and because the internal angles of any triangle sum to 180 degrees, 90 is already down, so is 30. We know the complement to 30 degrees is going to be 60 degrees, okay? So these are the two angles that we're going to work with to define our cofunction concept, okay? All right, so we have to note now that because we have these angles, the ratios of the sides of the triangle are going to be as such. The side opposing 30 degrees will have a fractional ratio of 1 if you were to, compare it to the hypotenuse length or the adjacent side, or what corresponds to the x-axis for the angle in standard position. Okay, and the hypotenuse will have a ratio when you narrow everything down of 2, and the side opposing 60 degrees has a ratio measurement of the square root of 3 or radical 3, however you like to call this concept, okay? All right, so yeah, the sine of 30 degrees and the cosine of 30 degrees depend on the fractional ratio of the hypotenuse length to the opposing side, but in the case of the angle in standard position, it would just be basically the y coordinate, okay? But whenever we're dealing with an angle that's acute or obtuse, whatever, that's not in standard position, we would say that the sine is the ratio of the opposing side over the hypotenuse length. So just to be safe, you could always look at the opposing side over hypotenuse length, okay? Because people sometimes don't catch right away how to reorient themselves when they're not in this comfortable standard position for their angle of interest, all right? So it's going to be that the sine of 30 degrees is equivalent to basically, as I said before, the opposing side, but since we're in standard position, it would be the y coordinate divided by the hypotenuse length. And the exact value obviously is going to be 1 over 2, or 1/2. So we know that the cofunction of the complementary angle 60 degrees is going to have the same value of 1/2. And obviously the cofunction would be the cosine of 60 degrees, okay? And we know that the cosine of 60 degrees is going to be the adjacent side, which has a fractional ratio of 1. And you're going to have to divide that by the hypotenuse length, which we're calling r here, and that has a measurement of 2. So it's also equivalent to the cofunction of its complementary angle, and it has an exact value of 1/2, okay? Another example of a cofunction pair is the tangent-cotangent concepts. So the tangent of theta is obviously, of course, an angle in standard position is going to be the y-coordinate divided by the x-coordinate of the point P where the terminal segment ends in quadrant 1. The vertex of the angle being located at the origin makes things really easy because it's just 0, 0. So this doesn't get factored into much of the trigonometric calculations, or any at all, actually. And then obviously the cofunction, which is going to be the fractional reciprocal of y over x, would be the cotangent. Here goes that co prefix. And for some particular angle theta, it's going to be equal to the x-coordinate divided by the y-coordinate. Or if you're not an angle in standard position, it would just be the adjacent side divided by the length of the opposing side, okay? And last but not least, the third set of trigonometric cofunctions is the secant of theta, which is equivalent basically to the hypotenuse length divided by the x-coordinate of that hypotenuse length for an angle in standard position. And if you're not in standard position, it would just be the hypotenuse divided by the side that's adjacent to the angle. And of course, you're going to have your cosecant, okay? And the general rule for finding the cosecant is going to be, again, the hypotenuse length of the angle of interest divided by the opposing side, or the y-coordinate of this hypotenuse length, okay? Yeah, so that's pretty much it. Intellectual comprehension of this material is not difficult at all, and after the short amount of time it takes to complete the entire Cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept. So good luck studying, and be sure to inbox me at emedicine@gmail.com to order this complete Cram session.